Alright, so this video is intended to help you with the standardizing the NaOH solution lab, specifically the questions with that lab. That's the picture you might not have been able to see super well on your copy, but hopefully you see the burette containing your titrant, which is allowing the analyte, the solution of KHP, to be neutralized by the base. And because we have a set amount of KHP in the Erlenmeyer flask, we should be able to determine exactly how much of the NaOH was used to neutralize that KHP, and from that find its concentration. As a reminder, I did do steps 2 and 3 for you prior to the lab. I went ahead and prepared the NaOH solution with a volumetric flask. I'll remind you of what a volumetric flask is towards the end of the lab, but that was prepared for you. So basically you started with step 4, where you measured out a certain amount of KHP. I believe it was around 0.51 grams. You dissolved it in water. Didn't have to be exact, but you've got approximately 50 mils of distilled water into your Erlenmeyer flask. You got to add the phenolphthalein solution and play with the magnetic stir to get the solution to dissolve. We then added NaOH to the Erlenmeyer flask while it was stirring, looking for a color change, which was an indicator that the reaction was complete, that the equivalence point had been reached, and that both reactants had been consumed completely. They were both limiting. And when we saw that light pink color, we knew the reaction was finished. So you recorded in your data table the masses of the KHP you used for your 2 trials, the initial and the final volume. Hopefully you recorded those accurately. Then the net volume would just be the difference between the final and initial volume. Trial 3 you should have gotten from another group. So question 1 asks you to calculate the moles of KHP used to neutralize the NaOH solution for each trial. Again, for each of these, with the exception of the average and number 4, because I'm only going to have you use the average concentration to calculate the percent error. You only have to show one calculation. The only thing we know about KHP before we finish with the lab are the grams of the KHP that you added to your Erlenmeyer flask and then dissolved. So you should figure out from the grams of the KHP approximately how many moles of KHP were used to neutralize your NaOH. As a friendly reminder, this was on the pre-lab, but just so that we make sure we all know that we've seen this again. The formula for KHP is not a potassium, a hydrogen, and a phosphorus atom. It is KHC8H4O4, as it has been bolded and highlighted on the document in front of you. Okay? So when you're going between grams and moles, do not just use the molar mass of K, H, and P. Then ask you to calculate the molar concentration of the NaOH solution you prepared for each trial. Obviously, I prepared the NaOH solution, and I told you that it was approximately 0.1 molar. I want you to determine the exact concentration of the NaOH solution. What you know at this point is, again, the grams of the KHP, and you know the volume of the NaOH solution that was added, and that would be the net volume for each of your trials. Sorry, Snow decided to say hi. Alright, and if you remember back from your pre-lab, I told you that the 2 react in a 1-to-1 stoichiometric ratio. So what that means is that for every 1 mole of KHP that was consumed, 1 mole of NaOH solution was also consumed. So if you know the moles of your KHP, you know the moles of your NaOH. And molar concentration is determined by molarity. And molarity would be the moles of your solution over the moles of your solute, specifically the NaOH, over the liters of your solution. So you have the liters of your solution, and you have the moles of the KHP from step 1. So I think you should be able to use that and the relationship between KHP and NaOH to calculate the moles of NaOH and divide that by the volume of the NaOH added for each trial. Okay. Your molarity should be close to 0.1, but I do not expect it to be exactly 0.1, in part because you can't weigh out NaOH precisely, which is why we're trying to standardize the concentration of the NaOH solution. Number 3, you're going to take the 3 molarities that you calculated for number 2, and for number 2, you just need to show me one trial, but you need to show me all 3 answers. And then for number 3, you need to calculate an average. I do not need work for this question. No work necessary. But I do need an average molarity. So I'm going to go back up here, and again, you need to show one calculation, but there should be 3 answers for number 2. And in number 1, again, you need to show one calculation, but there should be 3 answers. Or something indicating why there aren't 3 answers if there was a duplication of one of those values. Number 4 says compare the actual molarity of your NaOH solution with your goal of 0.1 molar, because 1.1 molar is what we were trying to make. So you're going to calculate percent error. The experimental value for percent error will be the average molar NaOH concentration. The actual value, again, is what we were trying to obtain. Now you should be able to get that for number 4. You do need to show work for this. And I would love it if you would round your answers to 0.1%. Alright, so those are the calculations. We went over those in class. So now we're going to take a look at 5 through 8. Why was it necessary that the NaOH solution be made precisely with a volumetric flask, while the KHP solution didn't really need a specific amount of water? Alright, so we saw in questions 1 through 3 that the ratio of KHP to NaOH is 1 to 1, and that we need to know specifically the volume of the NaOH solution we added to determine its concentration. We also just needed the mass of the KHP to determine the moles that were added to or used to titrate. So what I want you to think about, why was it important for me to be specific when preparing the NaOH solution to try to make it as close to 0.1 molar as I could, but why was it not so necessary about the KHP? How did the KHP relate to the NaOH? Think about the calculations you did. Okay? I hope that's sufficient. If you need more help, come and see me. Number 6, what are sources of error that would cause your average molarity to be more or less than 0.1%? Sources is plural. So that means you need more than one source of error. Okay? What are reasons that you could have had a concentration less than 0.1? What are reasons you could have had one more than 0.1? Think about what all you did in the lab. Obviously, I prepared your NaOH solution for you, but even if you take that out of the equation, think about what you measured out. Think about what you took measurements of during the lab. Again, calculations are not a source of error, and you will not get credit for calculations mistakes. Think about what you did in the lab. What are things that could have affected your calculations in numbers 1 through 4, and what are things that you could have done differently to get either better data or possibly even worse data if you had not done the procedure correctly. Okay? If you had not performed the procedure correctly. Finally, number 7. If you had not allowed the solid NaOH to completely dissolve before pouring the beaker's contents into the volumetric flask, how would the molar concentration of NaOH been affected? So according to the procedure for steps 2 and 3, you were to weigh out so much NaOH, and you were to add it to about approximately half the amount of water that you would need to bring it to the final volume of 100 milliliters. If you had not completely dissolved the NaOH before you added it to the volumetric flask and brought it to the final volume, what would that have done to the concentration in theory that was in that volumetric flask? Would it have been more than 0.1? Would it have been less than 0.1? Would it not have been affected? And then I want you to tell me why. Okay? And it is one of those three. It either didn't affect it at all, it affected it by lowering it, it affected it by raising it, and you should be able to tell me why based on the fact that we're saying that not all of it dissolved. So another way to think about this is if you are making Kool-Aid and you want to pour it into a new pitcher and you don't dissolve all of the Kool-Aid in the pitcher that you started with, how will that affect the Kool-Aid when it is poured into the new pitcher? Number 8. If you had added water past the calibration line on the volumetric glass, so if you had added that up here to kind of where I'm scrolling back and forth, how would the concentration of NaOH been affected? Again, would it have been less than 0.1? Would it have been more than 0.1? Would it have not affected it? Would it have been at 0.1? Molarity is a ratio of moles of solute per volume of solution. So if you had added more water than you were intending to, how would that have affected your concentration? And again, explain why. Again, it is one of those three, and you do need to give an explanation for why you think that. And that is the end of your lab write-up. If you have any other questions, you know where to find me.